Hello wonderful faces, welcome back to my YouTube channel. My name is Aryan and today I'm going to teach you all about scalar, vector and their representations. What is a scalar quantity and vector quantity? Let's start with it. A scalar quantity, right? The name and the meaning of this term is totally different than what it actually is. All those physical quantities which can be specified by a magnitude and they have a proper unit are known as a scalar quantity. Let me delvely explain this explanation what it actually is. The word magnitude is a number in simple words. Okay, and of course you guys know what is a unit, kg, mole, kilojoule, etc. These are all about units. A quantity that is having a unit, a specified number, a specific scenario at a one certain point is known as a scalar quantity. Again, I am rephrasing my words that a scalar quantity is a quantity that always stays at a place, works upon a thing, and actually gives a magnitude using units. That is how the scalar quantity works. In simple words, it's work only at a one point. Meanwhile, the vector quantity, as the vector word describes direction, it means it's having magnitude, unit, and direction all in three, right? Because they obey the vector algebra. What actually the vector algebra says is a thing, a place, a rotation, all the directions, all certainties that are counted in a direction is known as a vector. For example, I am moving from point A to point B. Right here, this is a vector quantity. Of course, if someone is beating me and they are applying force on me, that means it's a scalar quantity. That's a bit a rude example, of course, but yeah, definitely you can take it as example. So yeah, there are such examples given upwards as well. For example, for scalar quantities, um, length, right? And for vector quantity, there are few particular examples such as displacement, right? Torque that moves around a point. Meanwhile, linear equation, of course, moves in a line. All the things, all the terms defines a movement in it, right? Momentum itself, a speed of a particular object, that is known as a momentum. Yeah, so that's how I describe it. Okay, now let's look up to representations of vectors. um, my bad. Representation of vectors. What is an analytical vector, what is a graphical vector? Let's look deep into it. A analytical vector is defined as a arrow. For example, point A plus B, right? Right now it's a simple scalar quantity. Meanwhile, if I'm adding a representation on it, that is an analytical representation, or you can simply say symbolic representation. That is what an analytical representation means. We represent a symbol on a specific number, on a particular value, and then showcase that it is a vector or non-vector, means scalar force. Yeah, in simple words, it's a symbolic representation. The same example is right here, you can just copy paste right here. Of course, now we will move forward up on our next topic, that is graphical representation. As you guys know, there's a graph with x y axis, upon it minus axis, plus axis, y axis, negative y axis. That's how we define a graph. A representation on a graph is known as a graphical representation in simple words, right? For example, there is a graph here, um, and I'm having a point A and point B. The question says you have to make them together starting it from an initial point. The initial point is known as a O. So this is our initial point. This is our point number A. This is our point number B. The point number A moves in a straight line. Meanwhile, the question asks that you have to connect it in a way where the point B connects the tail. Okay, this is a tail, this is a head, tail of a point. So simply I'll draw it like this. Now what will be the point that will cover this distance? So simply we will denote it as a r. R represents here a resultant. Okay, starting it from a initial point O, going towards A point, then connecting B point. Meanwhile it gives us a resultant as a random value. Okay, so that's how I define a rule that is known as a head to tail rule. Now we will simply look up to it in difficult words as well, or I can say we will simplify it as possible it is. Okay, so in addition of vectors by head to tail rule, r is equals to resultant. Meanwhile a and b are the moral values of the quotients, and o is our initial point. Meanwhile the derived formula for it will be r is equal to a plus b. Right here the answer will be r is equal to a plus b. That's how I propagated the whole scenario for this graph, and this is our graphical representation as per the example. Okay, so the point where it interacts with each other is known as a vertex. Remember this thing as well. And this is whole a graphical representation. Meanwhile this was our head to tail rule. There will be a separate video for it where I will simply describe what actually it looks like, and parallelograms, the hard structures, hard diagrams that are actually valid for our this topic. These are the basic diagrams that we have created right now. For example, I can create a square, I can create a rectangular shape, I can create a triangle. These are simple, but we have to look forward to it by such complex structures as well, such as a parallelogram, as we did in maths last year. Okay, so this was all about first year's new book, graphical representation, analytical representation, and vectors, scalar quantity as well. Thank you for watching my video. That was it for today. See you in our next video. Bye bye, sayonara, arigato.